Hi everybody, my name is Matt, also known as Light Client, the green pyramid dots on the internet. This is my colleague Ansgar, and we're going to tell you about 3074 today. I was curious, who has a rough idea already of what 3074 is? Who has a great idea of what 3074 is? Great. Who thinks 3074 is a bad idea? Okay, we can talk later. So if you can leave this presentation with one thought, I would like it to be that 3074 allows EOAs to operate like smart contracts. This is something that there have been different ideas throughout the history of Ethereum to try and make EOAs more powerful. 3074 is a new idea to make EOAs more powerful. There's a lot of UX problems that exist on Ethereum, and there's a few that have specifically been part of the design of 3074, and so I wanted to go through a couple of them. As you saw in the last presentation, and anyone who's ever interacted with Ethereum, having to do separate transactions for token approvals is painful. And someone who has a pleb degen score, it's still painful for me. So this is a big problem. And more generally, actions tend to correlate one-to-one with transactions on Ethereum. And this is partially due to the way that we've designed contracts on Ethereum, but partially also just due to how Ethereum virtual machine is designed. There's no defense against lost keys, and it's unfortunate that the people who are maybe most susceptible to losing keys are the more novice users, the new people to Ethereum who don't really maybe understand the security models of these things. And they're the people who come in with EOA accounts and they just have private keys on their phone. And when they lose their phone or lose their mnemonic somewhere, they're the ones who are losing their funds. And I think it's really unfortunate that there's not a mechanism without forcing them to deploy a smart contract to recover those. So to me, that's a really big UX problem. I also think that not being able to perform actions without Ether is a big problem. Sponsored transactions, I think, is something that can help bring new people into Ethereum much easier. And I think that solving that problem at the core layer so that it's interoperable across all smart contracts will really help us bring new people into the space. A lot of times people might not even receive Ether as their first asset anymore. They might get DAI or NFTs, and we want them to be able to use these across Ethereum without having to pay Ether. And we looked at these problems and we tried to figure out why are these problems here, how can we solve them. And so we found that there's this root problem that contracts tend to authenticate things with this message.sender construct. I took a snippet from the ERC-20 implementation. This is the transfer function. And you can see that there's two parameters, this to field and this value field. And it kind of goes through. You don't pass in a from field, though. The from field is the message.sender. This is the person who's actually paying for the transfer. And the message.sender, it's this implicit authentication based on who called the function. And you just assume that whether it was an EOA that signed a transaction or a smart contract that called this ERC-20 token, there's this implicit idea that they authenticated that action, and so it's okay to deduct the balance from them and send it to the account that's listed as the to. And if we zoom out and we look at what is like a normal call graph for an Ethereum transaction, we see that there's only one time during a call graph where the EOA message.sender is equal to the user address. And so if you call contract A and contract A calls another contract and another contract, you never again have this property that the message.sender is equal to the EOA. And so if you're building a lot of smart contracts that rely on these things, like message.sender is used to authenticate it, then you have correlated your actions one-to-one with transactions. So there's been a couple solutions that have been proposed to get around these UX problems. And the first one is meta transactions. And if you're not familiar with what a meta transaction is, this is like a snippet from the ERC-20 extension for permit. Basically, what you do is you sign a message. This is an EIP-3074 message, and you say, I want to authorize this specific contract to spend some amount of my tokens. and then they do an EC recover to figure out who was the person who signed it, to figure out who authenticated it, and then they add that approval in the token contract. And you can probably tell by this meme that I don't think that this solves this problem, but the joke is that I am the clown because I thought this was the solution in 2018 and I was a really strong meta-transaction person. But after a while, it just kind of became clear that there's a lot of things that existed on Ethereum before meta-transactions, and meta-transactions require that we have explicit support in the contracts. And if you don't have explicit support, you have to redeploy your contract. And this fragmentation is really one of the biggest problems when you're trying to build interoperable standards on Ethereum. And it kind of turns into a negative cycle where you have this standard that works, but you need everyone to support it, but the tools don't support it because everyone doesn't support it, and then everyone again doesn't support it because the tools don't support it. And so it creates this negative cycle. And so then there's another solution, smart contract wallets. And smart contract wallets are great, and they're kind of like a superset of what you can do with 3074. With 3074, there's always kind of this EOA that has like control. You can't have good spending limits. You can't have great, true multi-signature wallets. But they're expensive to deploy, $5 to $100 to $200, depending on what the gas price is of the day. And there's a really big difference between something that's free and something that costs money. And if we're trying to onboard lots of users, the activation cost of getting them just to deploy a smart contract wallet, even if it's the simplest type of smart contract wallet, is significant. And there is another small issue that smart contract wallets can't instantiate transactions. And so if you have a Gnosis safe, you still need an EOA to actually send the transaction on chain, or you need to find a relayer to relay your transaction. And I think there's going to be ways to get around this. But at the end of the day, like what we want is we want to solve all of these problems for all users. And these last 2 points are like really important. We want to do it for all users, and we want it to be free. So now I can like talk about how 3074 actually works, and we'll like see how do we do it for all users for free. The two opcodes that 3074 introduces is Auth and Auth call. Auth is kind of the magic behind 3074. It takes in a signature and it takes in a commit, and we'll look into more exactly what this commit is, but you can think of it as a hash of the actions the user wants to perform. It returns the address that signed this auth message, and it adds a new context variable into the EVM called authorized. Once you've called this auth opcode on a valid auth message, this context variable is set as the EOA that signed it, and then you can invoke the auth call opcode. It behaves almost exactly like the call opcode does today, with the slight caveat that it takes the authorized context variable and it plugs in as message.sender. And so this gives us this property. Now we can arbitrarily set message.sender throughout the execution of a transaction. So if we look at the high-level flow about how this would work on mainnet, you can think of it as the user might sign a message, they send the message on chain through some mechanism, the contract would then verify the message, the contract would parse the message into actions, and then each of those actions would get executed. And a couple examples of 3074 things you might sign something that says approve DAI and then trade for ETH. Or if ETH drops below 1,000, buy 1 ETH. Or if my nonce hasn't been updated for 3 years, then allow X account to make transactions on my behalf. And so any of those things are things that you would sign, it would become part of the commit, and you would send it on chain. And this contract would invoke the auth opcode, and it would recover that address that is your EOA that signed the message. That would then parse all of those actions that you had signed and then execute them one by one with the auth call, calling out to your token contract or to your Uniswap contract to do the trade. And in the 3074 world, we call the contract that does these actions the Invoker Contract. And this is a really important part of 3074 because we're basically creating a smart contract wallet that everyone passes through. And so the Invoker Contract is a very important part of the 3074 world. We would say that it enforces the rules that are encoded in your commit. Because the protocol isn't the one enforcing things like replay protection or whether your trade went through or any of these things, you're basically delegating your trust to a smart contract, just like you would delegate your trust to a smart contract wallet if you decided to deploy a smart contract wallet instead. If we look at what the auth message format actually looks like, the thing that you're signing as a user using 3074, it looks something like this. There are these three elements: the type byte, the invoker address, and the commit. And you can think of the type byte as this discriminator that sort of discriminates, so it says only messages that start with the byte 03 are valid in the 3074 world. And so that gets rid of anything that was signed under like 721 or EIP-191 or transactions. None of those things can be considered 3074 messages. And then it further constricts the domain of things that can be signed in the 3074 world. And so you bind your message to a specific invoker. This is similar to saying, I trust Gnosis Safe, so I will deploy a Gnosis Safe. It's just the reverse. Rather than signing a transaction that deploys a Gnosis Safe, you just sign a message that says, this is the invoker that I plan to use. And then the commit is an arbitrary 32-byte value that commits yourself to some actions that you want to perform. And the invoker will then parse that, recalculate the commit, and make sure that those are the things that are done. And so what might a commit look like? You could have a really simple commit that's modeled similarly from the transaction. It could just be a nonce, a to, a gas, a call data. You can do more complicated things. You can have multi-calls. And so you would call the auth one time. You would recover the address that signed this specific auth message, and then you would just loop through the actions for each of these calls with auth call, and you would send these out. So that's kind of like the idea for 3074. If we looked at like a more full use case of 3074, there's two different types of use cases to consider. The first one is a self-sponsored transaction, and I think that this is this top line at the very top. So the transaction is sent directly from the EOA. This means that they're not going through some different service to send the transaction. And so the way that works is the user signs their auth message and they directly send the transaction with that encapsulates the signed message into the invoker on chain. If you go through the sponsored route, you would send your auth message to the sponsor, and they would determine if that's something that they want to relay. You might say, I will pay you like 5 DAI to submit this transaction. They'll look on their end and they'll determine if that's worth their effort. And if it is, then they'll wrap the transaction and submit it on chain. Once the auth message has been submitted on chain, it will go to the invoker, and the invoker will run the auth opcode on that signature. It will recover the EOA that signed the 3074 message, and then it will set the authorized context variable to that EOA. At that point, it will again parse the actions and go through some sort of loop and just execute each of the actions that were listed in the commit. And so it would auth call out to the user's target that they specified. That would return. It would again auth call whatever was specified. At the end, if you went through a sponsored transaction route, you might need to pay your relayer. And so at the end, you could have some sort of payment that goes to a token and then sends the balance to the sponsor. And then at the very end, you of course have like the return value that goes back to the user. So I painted the super rosy picture for 3074. There are of course pitfalls for 3074. It's important to understand how significant the care required to develop these things are. This is like developing a smart contract wallet, except not one that tens of thousands of users will use, but one that potentially every user on Ethereum might use. It's the kind of security the care of security that went into the development of the contract for the beacon chain deposits. It's really, really important that everything is done safely and securely. This isn't something that you do one audit, this is something you do 2 audits and that you formally verify. I think like developing an invoker, I think the cost and the difficulty of developing will mean there are on the order of tens of invokers to really exist. It's such a large effort, such a public goods effort, that I don't expect dApp developers to be using these types of opcodes. This is really something that's going to be a public good that everybody will be interacting with and will hopefully be developed in the open through community funding. A current caveat of this EIP is that Ether can't be transferred from EOAs. And the reasons why are probably out of the scope of this talk, but we think that we can remove this restriction in the future, and we've actually written it into the EIP, so it's very easy to remove the restriction if we can show to the other client developers that it's reasonable. And if you look in the EIP, I didn't specifically go over this, there's two different value operands for the auth call opcode. There's value and value ext. Value actually deducts the balance from the invoker contract, and value ext would deduct the balance from the EOA, the address that was set as the authorized context variable. Right now, the EIP specifies that invocation of the auth call opcode is only valid if the ext value is 0. In the future, hopefully we can remove that restriction and allow Ether to be spent. Self-sponsoring transactions are a great use case, but unfortunately they break a weak form of flash loan protection. By break a weak form of flash loan protection, I mean some contracts have this line where they say require tx.origin equal message.sender. And the thinking behind this is that the only time that can be true is in the first frame of execution. And if it's true in the first frame of execution, then there was no way they could have gone out to a flash loan and brought in a few $100 million. I say this is a weak form of flash loan protection because there are people with hundreds of millions of dollars that can come into your contract and break your economic assumptions. There's flash bots that could allow multi-transaction flash loans. So it's not really the strongest. We've also had an audit done that empirically analyzed mainnet contracts, and it doesn't seem like this is going to significantly break many things. So I'm going to hand over the mic to Ansgar. He's going to talk about some of these use case and examples, and then at the end we'll do some questions.
Good. How do we use the click?
Just
okay.
Right, left.
Hi all. Yeah, so Matt already kind of explained the functioning of the EIP and the design philosophy, and now I wanted to just go through a couple of very concrete use case examples, and the lens through which I want to do this is what I call like the spectrum of trust. And so what's the spectrum of trust? Well, in 3074, there are generally two parties involved. There's the party that signs the message, so that is the EOA that you use to sign it. And then there's, of course, the party that ends up putting the transaction on chain. And as Matt was saying, sometimes that can be the same in what we call self-sponsoring. Could be some external party. So basically, the question is like, how is the trust relationship between the two? And depending on that, like the role of the invoker is to mediate that and make sure the use case can be done in a secure way. And that's basically the lens I want to talk about. And then there's like an exception, an interesting one that's called synthetic EOAs, which I'll touch on at the very end. Quick disclaimer, I'm not so great with like graphics and memes and so on, so you have to like bear with me here. Not quite as shiny as the first part. Okay, let's go. So the simplest example, and Matt of course already kind of touched on that, is just batching transactions. So because usually you can only have one top level execution. So the nice thing now is that with 3074, basically, you can just sign multiple actions, and that means, I don't know, Uniswap, you approve, and then you transfer a token, and all of that is now part of one kind of outer transaction. The interesting thing here regarding this trust aspect is that if you have an invoker that already ensures that basically it requires that the sender that calls into the invoker is the same as the signer of the message, then you don't have to actually use the commit for any further restrictions, because then there's already perfect trust, right? It's the same person, so there's no kind of like implicit trust assumption. So you don't need to actually use the commit, and the nice thing here is you don't need to build in any like replay protection or anything. And that makes this kind of invoker super efficient. So basically, right, because like even a single S-store and like S-load, they are really expensive. So bundling that way, not only do you have great UX improvements, but you also have really kind of significant gas savings. I think, Matt, you looked into that, right? That even like, at least in high gas situations, just Uniswap users alone would save multiple $1 million per month just on this. And so, yeah, so we don't need replay protection, we don't need revocation mechanisms. There's like a full trust in this specific scenario. Let's now look at the second one. And this one is conceptually, I find even more interesting. And I think, Matt, you only had like at the very first slide, you said like one of the things EOAs currently can't do is like a protection against lost keys. And I wanted to basically get back to this and explain how 3074 changes this, because this is really interesting. Usually, like when you create a new account, MetaMask or something, it gives you the seed phrase and you write that down and then you hide the piece of paper, right? But there's always this implicit tension between being very safe, that you never lose the information, so might want to have it at in multiple locations or whatever, but you also want to keep it secure, right? So you don't want like that anyone, I don't know, robbing your place easily can just find that piece of paper. And so there's always this kind of implicit tension. Whereas in the, and also users might just be lazy, right? Like, I don't know, I have definitely for like throwaway accounts in the past, I've not bothered writing the thing down, but just copied it over in a text editor or something. It's not ideal. And so for smart contract wallets, on the other hand, we have this very sophisticated world of recovery options where you can have social recovery where your friends can basically come in and recover access to your account, or you could have just multiple other accounts set that like in a multi-sig fashion can recover your account, and you can have additional restrictions, say only if you haven't used the account in a certain amount of time, or if they want to try and recover it, you have some period in which you can intervene, all of this. And basically with 3074 now you can put all of this into an invoker. So you use the commit field to specify the exact recovery conditions, and you sign the message. Once you create the account, you put it somewhere where you can't forget about it. You don't have to keep it safe because no one else can use it. So you can even, if you really want to, you can even put it on chain. And then if you ever lose access to your private key, no problem, you can still use the account. So of course, I mean, ideally you'd want to move out of it, but at least you don't have any stuck funds, any lost funds. So this is really nice. And now if we basically go through these trust categories again, so we still don't need replay protection because like once you're authorized, it's like you specifically, like the whole point here is indeed you can't even have replay protection because you want this one signature to be used to like take over full control of your account. That's by design. But in this case, it's actually really useful to have revocation abilities built in. So basically, if at some point you had social recovery, but either like your friends end up not being your friends anymore, or maybe just like their machines were compromised or something, you can always like just go to the Invoker Contract and they just have some in-storage revocation mechanisms. And so in this case, you could say the trust is kind of partial. You have like more restrictions in place with the commitment and everything, but it's still, you still have some trust assumptions that once they are authorized, you fully trust them and they get control over your account. And then, and maybe like just briefly, and I think we have time for that, just briefly take that as an opportunity to like, just for a minute, talk about here the philosophy. Because of course, key recovery, again, is something that you already get with smart contract wallets. And batching, you also get with smart contract wallets. And so so basically like, what we want to do is not, we don't want to kind of like, replace smart contract wallets, quite the opposite actually. So Ethereum, like in the future, has these plans that we want to move away from EOAs and we want to move to the smart contract world. But right now, there are multiple challenges with it. It's expensive, only power users can use it, but also things like, just because it's such a small user base that uses smart contract wallets, a lot of the things just aren't supported by dApps. So like, for example, bundling. Many of these smart contract wallets have bundling abilities, but because the Uniswap interface does not allow for you to bundle the approve and the transfer, you still, even as someone with a smart contract wallet, you basically still have to do them separately. And that's just because the user base is just not big enough that makes sense for them. In this world, where now all of a sudden all accounts get this kind of what I would consider a minimal version of a smart contract for free, basically. Now all of a sudden, of course, all dApp developers have a user base that all want to be able to use bundling. And so in this world, we will basically much sooner start moving into these more smart contracts focused capabilities. And we have this much more gradual ramp up where basically new users get the smart contract wallet lite, and then you're already used to how to use all of these smart contract functions. And so if you ever then move to a full smart contract wallet, these things like social recovery and everything, they come very natural to you. And once we then move the whole Ethereum network to that, basically, hopefully with this EIP, we already kind of taught users how to use all of these capabilities. So that's the kind of way, because people came to us and were a little bit like confused of like, how does it fit in with the vision of smart contract wallets? That's kind of just what I wanted to briefly kind of to talk about. And then to come back to the actual examples, a third one now for the trust assumptions, right? We had like full trust, we had partial trust. Now to have like a example with no trust. Matt, you already also talked about this one. That's a transaction sponsoring. So I don't know, most of you might be aware of, like, for example, the gas station network. So there's these kind of systems where you have someone else pay for the transaction, and this is just like a really nice way of doing the 3074, which does not require this opt-in by every single dApp, and so it's just basically, it just works. basically. And if we just briefly look through the categories again, so this time, because of course you don't trust the sponsor, right? I mean, you want them to only do the things in your name that you actually want to be done. So this time you'd actually have to fully restrict all the operations in the commit. So you'd have to put all the like nonce, to, guess, call later, whatever you want to, the action to be restricted to, you have to put all of this into the commit. You also, that of course also includes replay protection, and importantly also because there's this attack where you sign a message and then they never put it on chain, and maybe it's a Uniswap trade, and then a month later they could execute it when the price is at a very kind of unfortunate other level, and then they could front run you, these kind of things. So in order to also protect against that, you'd also want to have like revocation capabilities. But all of this you can do very like natively with invokers. So all of this just works out of the box. And in this case, there's no trust between the signer and the party putting it on chain. And those were kind of like the three main examples. And then the last thing I wanted to briefly talk about is just what I mentioned earlier, what we call synthetic EUAs. And this is like a really interesting kind of fringe use case that turned out to also be really useful for 3074. And to explain this, just so the idea is basically in all the other use cases I talked about so far, the account that signed the transaction was a real proper EUA, right? So you have an actual account and you sign these messages. But the way these ECDSA signatures just happen to work, it's like a cryptographic quirk if you want to, you can also just come up with signatures that look valid, and you can like recover an address from them. But it's basically like an artificial signature. So there's no real account. You don't need a private key. It just gives you an address that's empty. So on-chain, there's nothing there. But it gives you control over that empty address, right? And that's a good thing because the address wasn't used by anything, because it doesn't have, it's not a contract. It also doesn't have a private key attached. It's just sitting there on-chain. But now you can basically take control over this with these synthetic signatures. And so like a very simple example, that's why I put it first, is just like centralized exchanges. If they want to have deposits right now, they basically have to give every user a different address. And then they have to go on chain and do all these collect actions, and it's really expensive. And what they could do instead is just, they give you just one of these synthetic addresses, and then they don't actually have to have ETH in these addresses or whatever. They can just like have one central invoker that then just iterates through them, and it's basically one withdrawal transfer and transaction instead of 1,000 for 1,000 users. So this is like a really nice application. And the interesting thing is, here trust is just not a thing, right? Because there is no actual account signing the messages, so we basically don't have to worry in that sense about trust. And like just two quick other examples of that use case as well, because it happens to also be like a really huge thing with 3074, and also illustrates the general point here. We want to make the opcode or like the EIPs as like flexible as possible to allow all of these different use cases. It's really supercharging EUA capabilities. So the second to last example here is also really interesting, actually. So it's one of these things that Matt listed as like things we can't really get with 3074. It turns out we can kind of get them. That is alternative authentication methods for accounts. So say I want to have an account that I can control with a BLS signature, right? What I would do is I would basically create one of these synthetic accounts, and then I would have an invoker that would only let me control that specific account if I successfully pass in like a valid BLS signature. And so that way, basically, all of a sudden, there is an account on-chain that can only be controlled with a BLS signature. So even this is kind of possible, although, I mean, I wouldn't necessarily recommend it, but it's definitely one of these things that just 3074 made possible that wasn't possible before. And last example in this category, and just basically the presentation was already finished without this, but then like we just had talked to people, and it's just so exciting to me, at least, this example, that like I really wanted to put it in. That's state channels, where I'm not sure how familiar most of you are with like how state channels work, but basically it's just two parties that exchange off-chain messages, and then at the end they basically close the channel on-chain on one time. It's basically a way of having high frequency communication, but you only have to touch the chain once to open the channel, once to close it. It's really efficient. But for many of these state channel use cases, you want to basically, you have some control over tokens or whatever, where maybe, I don't know, you have micropayments, and you stream some money or whatever, and at some point you want to stop, and now you want to redeem the tokens. And what many of these systems used to do is that they would then, once you actually want to close the channel, they'd have to do really expensive on-chain operations where they basically deploy a contract at a new address that then is basically in charge. It's what you might have heard of these counterfactual contracts in the context of state channels. It's really expensive. And with 3074, you basically get like a much cheaper way of closing your channels, because and also a way that is more robust against things like address collisions, where basically you just send your tokens at the beginning when you open the channel to one of these synthetic addresses, and then when you close the channel, you do that via an invoker, and then the invoker can just give you access to that specific synthetic UA. So basically, again, probably not too relevant for most of you here, but the kind of the takeaway here should just be this is like a single EIP that allows like a whole host of different use cases. And so it really, really supercharges what UAs are today on the network, while at the same time, hopefully just being the first step in the transition to full smart contract wallets and not kind of counteracting them. And with that, Matt, you want to do the final few slides first?
So just going back through these UX problems that we looked at the very beginning, Ansgar showed us how we don't need to have a separate transaction now for token approvals. We don't have actions correlating one-to-one with transactions anymore. We can bundle them all in one transaction and submit them through an invoker. We have a great defense now against lost keys. Immediately as you sign up as a brand new user to Ethereum or to MetaMask or whatever wallet, you can immediately figure out some social recovery mechanism, and we showed how you can natively have sponsored transactions supported without adding support to explicitly to any target contracts. So we solved all of those problems, the problems that we set out to solve with 3074. So where is 3074 today? We've proposed it for the Shanghai fork. The Shanghai fork is scheduled for some time in November, December, depending on when the ice age goes off. We've done 2 audits of the spec. We had an audit of the spec by least authority. They analyzed the specification itself, looked for security concerns that existed in it. We had an audit done by this firm called DDoB, and they did static analysis of some of the contracts that exist on mainnet, trying to see how are these things like self-sponsoring potentially going to break them. And we had pretty good results for both of these. And you should be able to find these online pretty easily if you go to the EIP and then go to the Ethereum Magicians link that's in the EIP. That's kind of the place where you can see all of the running information that's going on about this EIP. We do have a grant available for an Invoker integration prototype. We just got some funding from Moloch DAO. So if there are some full stack front-end devs who are really good with some DeFi applications that don't want to make a little bit of money, we would really like to have someone just try and implement this in maybe Uniswap so that we can show people like how much better the UX is going to be whenever we have these things. So our Twitters are on the next slide, and then, or come up to me after if you want to ask about that. And then last, we do have a testnet running if you want to play with these things. It's the Pushy testnet. You can access it on our GitHub. There's also a lot of resources on that GitHub page if you're interested. So these are our Twitter handles. Feel free to DM us with questions if you're here or live online. And then we're open for questions in person.
Hey guys. Well, so first of all, I think we talked about this on Twitter, but I thought I'd bring up the question again. I know I saw some developers that were talking about using basically these auth opcodes in their contracts. So instead of doing like a batched transfer from, that they would just use the auth directly to like transfer from the user tokens from a user's address. And I think we kind of talked about why. There's a number of reasons why that's a bad idea for security, for breaking composability. But so I think kind of one of the challenges is like how do we ensure that that this opcode is only used by like the few list of trusted invokers, and that developers aren't like putting this, basically giving like root access to EOAs in arbitrary contracts.
Yeah, that's a really good question, and yeah, thanks for bringing that up on Twitter as well. One of the really interesting things about 3074 is that it's this sort of honeypot for scammers to try and get you to sign one bad message and try and get you to use a malicious invoker. And if that ends up happening, it's kind of like you've just given your private key away to someone on the internet. And so we think that the way that this is going to roll out and be used by users is this is really like giving wallet teams a lot more power in the world. Like right now, wallet teams don't, EOA wallet teams don't really have much they can do. They can store your private key safely and have really nice UIs, But with this, they're going to be able to do batch transactions and support lots of interesting things. And so to keep their users safe, what they'll likely do is have a whitelist of allowed invokers. And that whitelist would keep dApps from just deciding to integrate 3074 opcodes in it, because the difficulty of the wallet team auditing those things is very high. They're going to expect several audits, formal verification, and dApp teams are not going to generally be able to expense those types of things. And also, like, that's a good point on the composability aspect. You don't want to have midway through a call graph expecting EOA signatures. That kind of like breaks the composability of things like smart contract wallets that may not have things that we understand as EOA signatures. And so that's like a community standard that we need to just say, if you're a dApp, you shouldn't really be using this. This is something that we need to think of as like a different level of smart contract, something that's a community good, like a community smart contract wallet.
Just to briefly add to this, so for one, it's really important to say basically your wallet wouldn't even allow anyone to request such a signature, right? If it's for an invoker that's not on their list, they just don't even ask you, do you want to sign this? They just reject this outright, so there's really like no risk there. And like more broadly, like the security model is really actually the same as it is today already for smart contract wallets, right? So similar to how you trust the Gnosis team that they wrote safe code, basically, and it's heavily audited, but then they can like write in all of these extra functionalities that they want, as long as it's safe. And this is basically the same assumption, just with the benefit that you would have these ERC standards, like you have an ERC 5000 invoker or something. So it's not only audited specifically for the Gnosis or for the Argent or for whatever wallet team, right? But it is audited for the community as a whole. So you can have even like more thorough audits. And so in a way, I personally would even say it's safer than the standard smart contract wallet trust assumption.
Awesome. Thanks, guys.
Thank you. So for the record, I'm the one that raised his hand when you asked if it was a bad idea.
I saw.
So what you're describing, both, I mean, and everybody's open, that's very nice. It sounds like a ticking bomb. And there are very good use cases, and it's also very dangerous. And you're starting to discuss about potentially restricting usage or reasonable usage to whitelists or invokers. And personally, I think that's not the philosophy of Ethereum, but again, that can be discussed. It sounds like the main use case to me is having someone else sponsor the transaction and batching transaction. And obviously, there might be additional very good corner case when you can do nice tricks, but this sounds like the two main use cases. And since the Berlin hard fork, we now have transaction envelopes. And there has been a proposal, EIP-3074, if I remember correctly, that proposed to support meta-transaction natively at the core protocol layer. And it feels to me like it would achieve almost the same goal with not as many downside, and maybe you can do a bit more with 3074, but you have to be very, very careful in Invoker, and I think this is potentially dangerous. So I'd like your opinion on 2711 against 3074.
That's a good question. So it's funny because 3074 as it is today has come down a very long path. I did a lot of work on 2711 and 2718 back last year when they were kind of being proposed. And I wrote another EIP, 2733, that's actually exactly like what you're describing. It expands on 2711, builds out more functionality. And I felt like it was very fully specified. And then I presented it to my coworker Ansgar and Sam, and they kind of shot it down because I was like, oh, we'll just do all of these things in the mempool. And it was a very brittle design that solved just those two problems, these like batch transaction and sponsored transaction, in a very brittle way. And the cost of implementing in the clients, I just didn't think we could convince core developers that just those two use cases in this one exact way that we think today is good was enough to bring that much complexity to the protocol. So they kind of convinced me that this like new mechanism, this 3074 style mechanism that's very expandable, you can design arbitrary functionality around this primitive. And I guess that's like where the philosophy that I have of Ethereum comes from. I, as doing core development, want to give developers like powerful tools where they can do really exciting things. And it's a bit of a balance. We don't want to give them tools that it's easy for them to shoot themselves in their feet, But if things can be used safely, and the EVM, you can do anything you want. You could design a token standard that's unsafe, and we still give people the ability to develop these kinds of standards. And so for 3074, I feel like if we help developers understand like what is required of developing safe invokers, we do the auditing and the formal analysis, we can have code that's safe. But it's a balance of, you know, how hard is it to make it safe? How likely is it for people to do bad things?
It's not just about developer, it's also about user signing the authorization.
This is the thing that wallets, this is the deal that wallets are going to come in and they're going to say, these are the invokers that we trust. This is giving wallets more power to try and have more functionality for their users. And this isn't really a different security model than already exists. Like your wallet has your private key and they can do anything that they want. They could deploy a new update that sends your private key to their servers or tricks you into signing something badly. And so we already have full trust in our wallet providers. And so I don't think that it's outrageous to expect to trust them to only whitelist things that are safe.
And maybe one last thing here, on like a broader protocol development philosophy point. I personally am very strongly of the opinion that it is not ideal to kind of like try and enshrine more specific use cases into the protocol. So like meta transactions. Now we create a new transaction type for meta transactions. Now maybe we create a new transaction type for social key recovery. Now we maybe create a new transaction type for, right? And like Ethereum historically specifically was founded even to kind of like move away from this special purpose blockchain paradigm as like the first truly general purpose blockchain. And and of course that comes with trade-offs, right? If you can do everything, you can do everything. But I personally very much like this model, and especially like if with this very clear understanding that like we just move to a similar security model as we have in smart contract wallets, but now also mediated by like UA wallets. To me, that makes a lot of sense. And importantly, instead of having the core developers that have, to be honest, relatively little contact with everyday users, like every use cases basically, instead of having them enshrine centrally like one use case and then 2 years later it reaches protocol and then you can basically, if you ever want to change something, it takes 2 more years. Giving the authority to like the user base and the wallets to kind of to build these standards, because once we have that in the protocol, you can have a lively conversation. What exact invokers do we want? How should they work? If we want to add another one, we can just do that without ever having to touch the devs process again. So it's trying to really unbundle these paths of innovation and iteration. And I personally, I think the criticism is definitely legitimate, and it's just like a hard call to make. But I personally am really convinced of this design philosophy, if that makes sense.
I think that's probably time. One more.
Last one. I was wondering if you could say something about the thought process of why the only thing that's checked in protocol is the invoker address. Like, is there a specific reason why there's kind of nothing else that you thought was worth just not having in the commit, but having checked in protocol?
Sure. This presentation I made a couple months ago, it's possible that we're going to add the chain ID as part of the commit, because we haven't had anyone come up with a good example to not do it, and there are a couple of footguns that exist if you don't include it in the commit. The main reason that we don't include anything in the commit is because whenever this EIP was originally written last fall, the original author, Sam Wilson, decided that he would have a precompile that you would submit your calls to. The precompile would have its own storage tree and it would do replay protection. And we felt that having a precompile with storage was too strange. It's a different paradigm for precompiles, and so we couldn't do that. And so then we made it opcodes, but we couldn't figure out, you can't update an EOA's nonce for the same reason you can't deduct their balance. We don't know where to put a nonce in the state tree. If you do choose a specific mechanism for a nonce, like a sequential nonce that it's always incrementing, then you can't do like parallelized nonces. You can't do just storing the hash of something. You can't do things like social key recovery. And so we tried to find a way to have a very abstract mechanism that could allow for many different things. And it turned out that not having replay protection we couldn't figure out a good way of having like the ability to do lots of things, without.
And also, just if you saw the 6 use cases I walked through, like there's only one of the 6 that actually would need replay protection. So it's really like by making it as abstract as possible, it is compatible with as many use cases as possible. And again, same design philosophy. We don't want to be opinionated. This EIP only for this use case. By keeping it, and again, you need the invoker in there because you have to be able to look at the invoker and the code to understand what's happening. We might need the chain ID, but besides that, leave it up to the individual use cases. This was our idea, at least.
It's probably time. Thanks a lot for coming. We'll be outside if you guys have any more questions.